Welcome students. We are going to discuss about polynomial congruences. So the idea is the following. You have f of x and you want to solve for f of x congruent to 0 mod m, where of course f of x belongs to z of x. That is another way of saying that f of x is a polynomial with integer coefficients. And we want to solve for f of x congruent to 0 mod m. So now, if you look at the prime factorization for m, so suppose m is p1a1 dot dot pkak, where pi's are the prime, So the way we'll proceed to solve this problem is, first solve for f of x congruent to 0 mod pi to the power ai, and then use Chinese remainder theorem to solve for f of x congruent to 0 mod m. So there are a lot of issues here which we can discuss. First of all, whether such a solution exists or not, and how do we decide whether such a solution exists. So before we go there, let's work with an example. So solve 2x cubed minus 7x minus 4 congruent to 0 mod 200. So again, the first step is to solve f of x congruent to 0 mod pi to the power ai. So let's see, your m here is 200, which is same as 2 cubed times 5 square. And we want to solve now 2x cubed plus 7x square minus the congruent to 0 mod 200. So first we'll solve. So this is equivalent to solve. So step one, let's say step one, solve 2x cubed plus 7x minus 4 congruent to 0 mod 2 to the power 3 and 2x cubed plus 7x minus 4 congruent to 0 mod 25. So this is what we'll do first, or 5 square, which is 25, right? And then use Chinese remainder theorem too. Then step 2, use Chinese remainder theorem. Let me use sorts of it, CRT, to find solution mod 2 cube 5 square. Okay, so let's do look at the first step. So step one, so for this problem, let's look at step one. So one, solve 2x cube plus 7x minus 4 congruent to 0 mod 8. So what you do is the following. You start with first, so 8 is 2 cube. So start with 2x cube plus 7x minus 4 congruent to 0 mod 2. Okay, so we'll start with 2. So the idea is start with 2, then lift that solution up to 2 square, then lift that solution up to 2 cube, if possible. So let's say mod 2. So this implies, well, 2x cube. So this becomes 2x cube plus 7x minus 4. This simplifies to, so 2x cube mod 2 is 0, 7x is 1, so x is congruent to 0 mod 2, right? So the solution is x is congruent to 0 mod 2. So this is your solution. So this means what? This implies x is some multiple of 2, so 2t. Now consider, so you should start with, say, let x be the solution. And you are planning to find out what the solution is. So what do we get out of this? So we get x equals to 2t. Let's put this back. So we get 2 times 2t cube plus 7 times 2t minus 4 congruent. Let's solve this now mod 4. Look at this solution mod 4 now. So what do we get? So if you go mod 4, this will become 0. This is 0 already. You'll get 14t, which is congruent to 2t congruent to 0 mod 4, right? So what do we get out of that? So therefore we get, if you look at this part here, t is congruent to 0 mod 4 divided by GCD of 2 and 4. So this implies t is congruent to 0 mod 2. This implies that t equals to some 2 times s. So now let's put that back here. So we get, therefore, our solution is x, which was 2t, which is now 4s. Now let's take this 4s and plug it back into the equation. We get what this implies. So plug it back, plug it into original equation. So this implies when you plug it in the original equation, you get what? You get 2 times 4s cubed plus 7 times 4s minus 4. Now we are trying to see the solution mod 8. So this will give me what? This is going to be, so this has to be 0. Let's work it out. So we get, so we want to see now solution mod. This should be congruent to 0 mod 8. So let's see what do we get out of this. So we get, so if you go mod 8, this will be 0 because it has factor of 8 in it. This will be, so we get 28 s minus 4 is congruent to 0 mod 8. This implies, now mod 8, what is 28? So 28 is going to be 4. So 4s is congruent to, bring this 4 on the other side. So 4 mod 8. Yeah, so this implies This implies S, using the cancellation property, S is congruent to 1 mod, what did we cancel? C. C is 4. 1 mod 8 by 4. So this implies S is congruent to 2, sorry, S is congruent to 1 mod 2. So therefore we get S equals to some K, 2K plus 1. Now let's put it back successfully to find what our X is. So our X is, from here you get 4S, which is same as 4 times 2K plus 1, which is 4 mod 8. So the X is basically 4 mod 8. So now we have found out solution of this equation 4 mod 8. Now this was 1. Now let's start with what? Now we want to solve the same equation, which is 2x cubed. Now solve 2x cubed plus 7x minus 4 congruent to 0 mod 25. So start with 2x cubed plus 7x minus 4 congruent to 0 mod 5. So let's see what is the solution of this 0 mod 5. So what do we get? So this solution, this can be reduced to 2x cubed plus 2x plus 1 is congruent to 0 mod 5. Now let's check a solution which will work. So you can see that x equals to 1 is a solution. Yeah, so is a solution, right? Because if you put x and then add all of them up, you get 2 plus 2 plus 1, which is 0 mods. So question is, are there other solutions? Yeah, that's a meaningful question to ask, and we'll see later in Hansel's lemma. Using Hansel's lemma, we'll see if there are more solutions. Okay. So right now let's x be a solution. So that means what x equals to, so x is 1. So you can see that x is congruent to 1 mod 5 is a solution. So therefore x equals to 1 plus 5t for some t belonging to z, right? Now take this solution and look at mod 25. So therefore 2 times 1 plus 5t the whole cube plus 7 times 1 plus 5t minus 4 is congruent to 0 mod 25. So you see that you're lifting the solution mod 5 up to mod 25. So this is called lifting of the solution. So now let's see what do we get. And such lifting may not be possible all the time. And precise answer to this is given by Hansel's lemma. So we get 2 times 1 plus 5t cubed plus 5t squared plus 5t. So this multiplied by 3, this multiplied by 3. This is the expansion for a plus b the whole cube plus 7 plus 35t minus 4 is congruent to 0 mod 25. So we need to solve this now. So mod 25, this will become 0. This will also become 0 because it has factor of 25 in it. So this implies 2 plus, if you look at here, you get 2 times 15 times 3, sorry, 5 times 3 is 15, 15 times 2 is 30, so 30t plus 7 minus plus 35t minus 4 is congruent to 0 mod 25. So what do we get? So therefore, we get, so 2 plus 7, 9, 9 minus 4 is 5, and 30 plus 30t plus 35 is 65t. 65 mod 25 is 15. So 15t is congruent to 0 mod 25. So now from here we want to solve for t. So let's bring this on the other side. So we get what? We get 15t is congruent to minus 5 mod 25. Now we'll again do the cancellation property. Note your c is 5. So if you apply the cancellation property, you get what? 3t is congruent to minus 1 mod 25 by 5. Yeah, your c is 5. So this implies 3t is congruent to minus 1 mod 5, or you get, now you can check what are the solution for this. So 3 and GCD of 3 and 5 is 1, which divides minus 1. So there is a solution. Let's see what is the solution to this. So we can do this by inspection. So let's take t equals to 1, won't work. T equals to 2 won't work, because t equals to 3 is 9 and 9 is minus 1. So t equals to 3 mod 5. So therefore t equals to 3 times s, sorry, 3 plus 5s. Now let's plug this back in originally for x. So we get x equals to, first of all, x was 1 plus 5t, which is same as 1 plus 5 times 3 plus 5s. And then you get what? 1 plus 16 plus 25s, which is congruent to 16 mod 25. So you have solved now. So this was your original goal. You wanted to solve modulo 8 and modulo 25. So now you have done that. Now we have to go for step 2, which is combining this solution using Chinese remainder theorem. So let's do that. So step 2, you have x is congruent to 4 mod 16, sorry, 4 mod 8. Let's check, is that correct? So yeah, so we got x equals to 4 mod 8 from here, and x is congruent to what? X is congruent to 16 mod 25. And now we want to solve the system of congruences. So recall, what was the solution to a congruence? So you had, if x was congruent to ai mod mi, then your solutions were what? Your solutions were x equals to where mi, mj are coprime for all I and j, I not equal to j. Then what was your solution? Your solution was, you constructed, so let's say there are k of these, 1 to k, and I not equal to j, and I and j are between 1 to k. Then the solution was given by the following. First you construct mi, which was take m1 to mk and divide by mi. Then find yi such that mi yi is congruent to 1 mod mi. and then you basically patch the solution up. So x equals to a1 m1 y1 ak mk yk, right? That was a process for your Chinese remainder theorem, and you were finding a unique solution modulo m, where what is your m? Your m is m1 to mk. So now we want to find out solution mod. So we want to find out solution modulo 8 times 25, which is 200. So what we'll do is, first we'll take a1 is 4, m1 is 8, a2 equals to 16, m2 equals to 25. So m equals to m1 times m2. Your m1 is m2, right? It's m1 times m2 divided by m1 actually, right? So these guys cancel out. So is m2, which is 25, and m2 is m1, which is 8. Now we have to find, so step 1, find y1 such that y1 times m1 is congruent to 1 mod 8, and find y2 such that y2 times 8 is congruent to 1 mod 25. So now we want to find the inverses of, so this can be simplified further. So this implies y1, what is 25 mod 8 is basically 1. So we get y1 is congruent to 1 mod 8. And what is my y2? So mod 25. So let's see. So y2 is going to be, so 3 8s are 24. No, that's not going to work. So 4 8s are 32, right? 4 8s are 32. That will not work. 5s are 40. That won't work. 6 8s are 48. No. 7 8s are 56. No. 8 8s are 64. No. So after computation, it seems that 22, y2 is 22. So therefore, why is that? Because y2 times 22 times 8 is 176, and 176 is congruent to 1 mod 25. So therefore, what is your solution? So x is going to be a1 m1 y1 plus a2 m2 y2, which means this is going to be a1, which is 4, m1 is 25, y1 is 1, and a2 m2 y2. So a2 is 16, m2 is 8, and y2 is 22. And this mod m, which is 200, will be your solution. So you can check that this is going to be 100 plus 2816 mod 200. That means if you go, is 2916, which is congruent to what? 116 mod 200. So the solution is x is congruent to 116 mod 200. So there are a few questions we should ask here. Given x, f of x is congruent to 0 mod p to the I, does there exist R such that f of R is congruent to 0 mod p to the power I plus 1. Okay, so we'll discuss this later when we discuss Hensel's lemma. Thank you for your attention.